Good morning, everyone. Hope you all had a good first day. Apologies for dragging you out of bed a little earlier for this talk. I know I'm dragging a little bit. Thanks for just some people in the front row. I hail from Vancouver, Canada. Canada, probably the most European country on the other side of the Atlantic. And I'm here to hopefully, to basically, as the title says, talk about lock files. I'm hoping all of you learn a bit and I get a bit of therapy out of this. So hopefully it's going to be a win-win for everybody. The QR code here is just in case anyone needs accessibility access to the slides, just to make it easier for yourselves. Yeah, these mics are way low. But it's not critical. But yeah. No. Just one shot. Okay, thank God. Okay. So without further ado, I'm just going to start off with some thank yous. So first, thanks to EuroPython for giving me this invite. I actually was invited to talk 15 years ago when this was in Birmingham, so it's great to be back. No real reason I took so long to get back, just timing, I just need to get over here. I want to thank my employer, Microsoft, for giving me time to work on this very long project, as the title said, 4 years or more, as we'll talk later, depending on how you want to measure this, and also helping funding a coach seat on a plane and the hotel and food and all that good stuff. But being the tall, snarky Canadian that I am, coach does not fit well. So I listened to Hinnick and upgraded to business class, so I get to thank my GitHub sponsors for helping cover that cost. So thank you to Astral, Troll, Timothy, Christian, and Mike. But for those who have not flown business class, that was still not enough money. So thank you to my family for willing to cover the rest and give me the time to come here. We have a 15-month-old who was unfortunately sick last week, so it was a little touch and go about coming. But thanks to my wife for not totally freaking out and saying, no, you can't go. And then finally, thank you to Russell and the Beware team. This is their project Podium, and I pestered Russell to no end with bug reports and issues and other things on this software, so thank you, Russell. So this talk's going to basically be about 3 parts. So we're going to talk about kind of what it takes to choose what to install. We're going to talk about how log files look, and then my therapy session about why this took 4 years. So to start, let's talk about what it takes to get something installed, right? How the heck do you get something from Pypi, and it is Pypi, to be very clear. Yes. I have a lightning talk I used to give where I very much clearly specify, yes, it's not Pypi, that's the JIT implementation. Anyway, so let's talk about how you get something installed. And there's 2 parts to it. So the first part is choosing how to install something, right? Which you would think is pretty straightforward, but no, we like to complicate our lives. So there's actually 3 different ways to get to it that all chain together to lead the same thing. But once again, we can't have nice things. So the first thing is a source tree. And basically what this is you can think of this as like a Git repo, right? Or a directory or something that basically has everything you need that has your source kind of raw as it is, right? So as I said, usually the Git repo is probably the best thing to think of. And this is probably the simplest structure you can have. I went so simple, I'm not even gonna use a package, single module, and it's 2 files, right? Your pyproject.toml, which specifies, and I'll show an example in a second of what that is. Basically specifies how to get this into a different form using a build backend and your code. As I also say, as an addendum, I do not condone using a SRC layout. Talk to Hinnick if you want to know more about why you might want to. I'm just old school, not my thing. But talk about that pyproject.toml file. This is the minimum pyproject.toml that you can have. Now there's slight variance because the version, which we will talk about later, can be dynamic, but it has to be specified somehow. I'm not going to get into details about dynamic fields, but basically it says the build backend, which in this case is PDM, can choose how to fill in that data later. So that's it. That's literally all you need to use a pyproject.toml file to get going. Technically, you can leave the build system out. I very much advise against that. It was basically a transition mechanism, and it works, but it might be a little surprising. So I would still suggest you always specify that. So source tree, Git repo, files and stuff. Okay, can't really install that, right? How the heck do you get Python to recognize all that stuff? Well, The next way is to distribute that source as is, and that gives you a source distribution. You may have also heard of this called an sdist. As you can see, not a lot more. There's one more file, pretty straightforward. You will notice the name of the file, though, is example-42.tar.gz. What that basically is just saying, like, hey, this is a project example. It is version 42, and we just chose tar.gz files as the way to specify sdists. Honestly, for historical reasons, not because we just say wanted to, because I'll show you something in a minute that's a zip file, so, because let's just change file formats, why not? It's just fun. But as you can see, really the only difference is one piece of metadata that wasn't there before, and it's otherwise the exact same thing as a source tree. So what the heck is in that package-info file? That. Yeah, pretty simple, not much. As you can see, it's basically a mapping from what was in PyProject.toml in that project table to another format. Interesting fact, this is the format of email headers. The reason that was chosen was this predates JSON, and we have the email package in the standard library, so someone thought it was a good idea to use that as the format to store data. If anyone is looking for another PEP to write, Savannah, you could probably write a PEP to try to move this over to JSON. There's actually already a PEP that was rejected for other reasons that has not an appendix, but a section that says how to map this to JSON, and no one's taken the time to basically try to help move the community over to using JSON instead of this. So, someone really wants to go for it. Go for it. All right, so, source tree. Git repo, directory nothing, sdist. What happened? A build backend basically took what was in your PyProject.toml, did some stuff, and wrote out the metadata ahead of time and just said, here's what I know so far. Might not be complete because of the dynamic thing I kind of mentioned, but I'm not going to get into. And just said, okay, I know some stuff. Well, all this leads to the infamous wheel. This is a zip file. To explain the file format, you'll see there's a bunch of dashed bits to it. So it goes name, version, the interpreter it's meant to work on, the ABI, which stands for Application Binary Interface, and then the platform. So for this one, it's pure Python, so we're saying it works on any Python 3 interpreter, hopefully. It doesn't have any ABI requirements, it's very much an extension module kind of thing, and it works on any platform, right? It's not restricted to Mac, not restricted to Windows. And if you notice, way more files, and where example.py exists actually shifted. Why is that? Well, the thing is the way wheels work, and why you should always, please, I can't say that enough, you should always push wheels to PyPI or anywhere else, because the way you do the install is you literally unzip this somewhere and copy files. There's no executed code, there's no backend to build, there's nothing. It's literally unzip this, copy that disinfo to the right place, copy the source to the right place. There could be a data directory in here for like your /bin or /scripts if you're on Windows stuff, but basically it's just literally just copy, done. Nice and fast, no security concerns from a weird build backend doing something funky, and this is why this is the end of the whole going from source tree and your raw source to a thing that can get installed, okay? Lots of steps. Okay, so now we know how to get something installed, right? Going from that source tree to an sdist to a wheel, and that's actually how pip and all the tools work, is if you give them a source tree, they get you down to a wheel. If you give them an sdist to get down to a wheel, it always goes through a wheel, no matter what. So, now how do we choose what to install? This is everything, and we'll break this down. But there are a lot of options to specify what you want to actually have end up in the end, okay? So to start, you can just specify a project, right? So we can just say we want our example, that's it. No restriction, just give it to me. Not gonna be specific, okay? That's usually a little too willy-nilly and a little too loose with everything, so that's when you start to do your version requirements. Like, I only want example if it's greater than 1.2.3, right? Anything older than that probably has some API thing I don't want, doesn't work, okay? But this can get very complicated. You can do upper bounds, which you should not do if you can help it. I believe Hinnick has a post, or just a post, not a video, on this. Anyway, don't do upper bounds, please. But this is just basically a way to say, like, I can't go lower than this because I'm using some API that was introduced at this point. Please do better than that. You can also have extras, which basically says install some extra stuff. I suspect Sebastian, with his Fast API talk later, will probably cover the standard and such extras that Fast API has. That's a good example, but basically this is just a way to say, I have extra stuff that I want installed that's not required, not necessarily what you want as the defaults, but I know the project knows they can do things and I want you to have it, okay? Effectively, it just tacks on a bunch of dependencies to the already list of dependencies that the project has, and just basically just elongates it. It's literally just an extend. Finally, you have environment markers, okay? So if you notice, semicolon, Python version less than 3.14, right? So what that's basically saying is, for this package, only install it if Python 3 is, if Python is older than 3.14, install this. If it's not, don't worry about it, right? So this is how you get like compatibility with like, a common one is typing extension, right? With typing extensions, you might need something out of it that only if Python's too old to have the thing you need, because it got introduced into the standard library in the typing module. So that's a common way to see this, right, for the Python version. But this can specify like the version of the Linux distro that you're using, for instance. It can be very, very specific. There's a whole list. But all of that, as I said, and unfortunately I screwed my slides up, and the order's out, but this is how complicated it can get, right? Now, why do I bring all this up? This is why sometimes it takes a while to figure out what to install, right? Let's say you take that list of your dependencies, right? Forget extras, it doesn't matter, but do the environment markers apply for the thing on each line, okay? What versions are required, okay? Figure that one out. Is there a wheel? Do you care if there's a wheel? What about an SDIS? What about a source tree? Once again, all those take extra steps to make them become that eventual wheel that you want to install. Do you want wheels more than you want newer versions, right? Because as I said, installing wheels, really nice and fast, but maybe the new version doesn't have wheels and an older version does. What do you prioritize? And then every time you install something, guess what? It has its own requirements. So you may have installed requests at the newest version available, and then someone decided to do the evil upper bound, and suddenly decided like, oh, okay, the one you chose can't apply because one of your dependencies says, no, that doesn't work. So suddenly, all that work you did to figure out what to install, thrown out the door. Doesn't work anymore. I got to redo all that work to figure out what the heck I want. So yeah, this is actually an NP complete problem. And so be a little patient and understanding with the pip developers when it takes a little while. It's actually a surprisingly hard problem. Okay, so a lot of stuff going on to figure out just what to install. Okay, why am I bringing all this up? Well, this is basically what goes into a log file, right? A log file is basically a thing to write down what you want to get installed. So you start off with listing your direct dependencies in pyproject.toml, right? And it's in the dependencies key and project. And you can list extras and optional dependencies. That's basically what your extras are. You also have dependency groups now, if you're not aware of those. This is a place where you can list like the things you need to run your tests or your linters or anything else that's not kind of like part of your public API, as it were, for dependencies for your project. But this is where you list all the stuff you directly require and need to use and work with. But obviously, all those things have their own dependencies. So you got to write all that stuff down. All right. Well, right now in the community, the way this works out is there's a couple options, right? Some of you might use pip tools, for instance, and write that down using your requirements.txt files from pip. You might be a poetry user and use poetry.lock. You might be a PDM user and use pdm.lock. You might be a UV user and use uv.lock. Right? Now, you might kind of be able to read ahead of foreshadowing on this one, but basically, I was crazy enough to ask the question, why can't we just have one of these bloody things? Right? It was basically a question of, for me, there's 4. They seem to have a lot of overlap. Standards are good. I have a penchant for writing PEPs. Well, why can't we just kind of get this down to one? Why can't we all agree, right? Why can't we all just get along? So, can we have just one log file format? Turns out, yeah, mostly. I'll clarify why it's mostly. There's some stuff in one of those log files I listed that's not standardized yet, so you can't quite get that into a standard. But given enough time and effort and lots of typing comments online, apparently you can pull this off. I don't know if I'd recommend it to anyone else, but it can be done. If you're looking for the standard, I'm going to go through it, but that's where it lives now, and you can have. You don't need to look at it right now. I'm literally going to go through it, but you can look at it later if you're interested. But yes, we can have a single log file for all of us. We can, hopefully, if you agree with me, have nice things. So what did we end up with? How did we get here? What did we want? So there were some design goals with all this. First thing, typically for log files, you don't want to write by hand, right? Software is going to go through, look at all your top dependencies, and go like, okay, request requires urllib 3. Okay, let's figure out what version of urllib 3 works, write that down, write down what version of request that you asked for, and just do that. Doing that by hand, not fun, don't recommend it. So we wanted to make sure this could be written easily by software. But you're probably going to have to audit the updates to this log file, right? You're going to want to know what the heck did this change, what did this update to, why is this new dependency suddenly showing up here, et cetera, et cetera, et cetera. So you want it to still be readable by people. Right? So you don't want a binary format. You don't want something that's hard to read. You want something that you could very much look at a diff and go, okay, that makes sense. You want secure by default, right? I take a perspective that security is great as long as it doesn't get in your way. So if there's a way to make things more secure and not make you have to do more work for it, that's definitely a win. And it's actually one of the major motivations for me doing this to make sure we kind of lock things down, not lock things down, that's a bad word, but make things more secure by default, because if you look at that requirements.txt file, there are basically 3 flags you have to turn on to really get a secure install on that stuff with pip. And I fully know, and I will fully admit, I don't always turn those flags on, just out of laziness. So how can we make it so you don't have to worry about that kind of stuff? Next, fast to install. No one wants to wait. There should be a way to make this go really, 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 really fast. Specifically, as I mentioned, resolving to figure out what needs to get installed. NP complete problem, if we can cut that out completely, way faster to do an installation. Next, we wanted the concept of lockers and installers to be separate. So think of a locker as someone generating the lock file, while installers is the code that actually gets the stuff on your disk and available to your environment to actually use. The reason this was done this way was we realized the tool you use to do that, to create your lock file, will quite possibly not be the tool that does the installation. Think of cloud hosting platforms, right? Like various places will take currently a requirements.txt file and automatically do the installs for you. You don't know what software they use to do it, and hopefully you don't care. You're just saying, I want this stuff installed. So the idea here is hopefully, with this being the standard, all these tools that do the auto install will recognize it, do it, and it will just work. And they can write in whatever language they want. We don't care, but it can't be too Python specific to prevent them from using Rust or whatever language they want to use. Lastly, and this was slightly hard lift to get, more foreshadowing for my therapy session later, getting single and multi-use environment scenarios supported. What this is referring to is you could have a lock file, you could imagine for Mac, and a lock file for Windows, and a lock file for Linux or something, or a lock file for Python 3.14, and a lock file for 3.12. But most of us don't want more files in our repository, so that's where these multi-use concepts come from, where can we have a single lock file that encompasses all those different options and writes it all down at once, and in a way that there's not a lot of repetitions, so this file doesn't get huge. All right. So let's find out if I pulled this off. So we now have a pylock.toml file. You can also have a pylock.toml file that has a little name in the middle, so pylock.whatever.toml. This allows you to have different log files for different needs. For instance, You could have a log file for all your newest versions of everything you need to test against, and then you could have like a pylog.oldest.toml that records all the oldest versions of everything that you want to install, right? Which could be useful in CI if you make a declaration that my bottom version is blank and you don't realize that things have shifted, or you haven't specified it before and you just want to test your oldest versions versus your newest to see if you accidentally need to actually raise your lower limit. That's a potential use of this. Or if you have a cloud provider that has a very specific requirement, they could have their own pylog.in-the-cloud.toml file that you can specify and have just the stuff you need for production. So, by the way, if you haven't noticed, it's a toml file. Mainly because PyProject.toml existed. If you really want to know why that was, go read PEP 518, and you can come yell at me about that later. So, what's in this file? So first off, there's some top file level details. One is specifying the lock version, because this is generated by software. We can use versioning, unlike with the project table in PyProject.toml, which means software can update as necessary. So we can bump this version as we go, add new features, everything should keep working, shouldn't break hopefully anything. Fingers crossed. Environments is a list that lists all of those environment markers that specify exactly what platforms this lock file supports, right? So this is where you can say, I support Mac, I support Windows, et cetera, et cetera. This is all using the same marker format that we showed earlier about how to specify what to install. I used Python version in the example, if you remember. Same, but it's expressive enough that you can specify exactly what environments. It requires Python, says what the actual version of Python is required for the overall lock file. You can say, I only work on 3.14, I need something newer than 3.10, et cetera, et cetera. Extras is what it sounds like from packaging. Because you can lock your libraries for development purposes, you can specify here like, hey, here are the extras that I potentially support, and as a name, right? Just like I mentioned earlier, there's the bonus example. I mentioned Fast API standard and stuff. Those extras can get listed here. These are the extras that are available. So this is kind of what you might show in a CLI, for instance. If you had like installer dash extra, the names of those extras groupings would be there. Same for dependency groups. Taking dependency groups from your PyProject.toml and just writing them out there. It's kind of just the top level thing to look at to understand what's in the file. As I said, this is designed to be human readable. I didn't want someone to have to read through the entire file to figure out what are all the names of all the extras? What are the names of all the dependency groups? How do I read it and understand what could be specified? Because this is all at the top. It's very easy to just glance, look, and understand what's there. Default groups is the default dependency groups that need to get installed. This was an ask from UV, because by default, UV will install its dev dependency group. So that just says, if no one specifies anything on the command line or however UX you use for your installer, this just says, if nothing's specified, this is what you should install. And then finally, just a little line to say what tool is used to make this. I will say lock version is the only thing required in that whole list. Everything else is optional based on need. Okay, so this is the data for the whole file. Now we get into the interesting details. So packages. If you're not too familiar with TOML, the double brackets basically means that's an array. So just if you say that multiple times, each entry becomes an entry in the array itself. So packages, they have a name. They can have a version. Once again, foreshadowing, therapy later. The marker is when does this package get installed? And it requires Python is, once again, a marker to say, hey, this has a requirement, and if this isn't met, there's an error, right? This is mainly just a catch-all. Name is the only thing required here. Version is optional. Marker is optional, and requires Python is optional. Marker is the one key thing here for deciding whether to install something, and requires Python is just a way to say, oops, I screwed up, I should not be able to install this, and error out. Oh, and one little comment, sorry, flashbacks. Marker, because it's environment markers, one of the things I had to introduce was, you can see down there, extras and dependency groups as new types of markers, because if you remember in the previous section, excuse me, you can specify the extras and dependency groups that are supported. So what you do here is, let's say you wanted to install your bonus extra. What you can do here is say, hey, install this package only if bonus is in extras, right? And extras acts as an array of any of the extras you specify in your UX as the extras I want installed. Same for dependency groups. I'll explain how general installation works later, but effectively, this is just going to be a huge list of packages. You need to be able to go one by one through them and say, yes, install this, or don't install this, skip it, or I should be able to install this, but for some reason I can't, error out. And that's how you say, oh, this is not needed because I didn't specify this extra, or I didn't specify this dependency group. Now, we're going to start talking about source trees, like we talked about earlier, because some people want to specify a source tree and then go from that all the way to a wheel. This work is actually based on the direct URL.json spec by Stefan Bidul and Chris Jordanek. The reason this is going to be a little different than the stuff that comes later is because if you think about it, you can't really specify you just want a project and find a source tree for it, right? If you think about Pypi, you don't say, hey, upload a source tree. You upload a sdist or upload a wheel. So because of that, you want to record the exact way to find this stuff, right? Because it's not a search for the best version. It's like, no, I need you to install the software from this URL or this path at this exact place. So for instance, if it's a Git repo or some version control system, right, you need to be able to install at a very specific point. So you can specify the type, and that's specified in the direct URL.json spec of what's supported. I think it's Git Mercurial and Subversion. Read the spec to find the exact values. You specify the URL or path to where this source tree is. You can specify the requested version. Think of this as like a Git tag. It's not really required. It's just to help you understand as a human reading thing what the heck this is. The commit ID is required, though. That's the exact commit you want. This is that security bit coming up. You don't want to say, hey, you know what? Just get me the source tree for requests. Yeah, okay, but which version, right? It's kind of shifting around all the time when anytime a commit lands on main. So you want to say the exact commit ID, because this also typically gives you a bit of security, because usually, like with Git, it's a hash, which helps validate the contents, so you can very much make sure you get the exact version of the bits that you want to get installed. And then lastly, the subdirectory in that source tree of where the Python code is, right? Because you could theoretically have a Git mono repo that's got like 5 Python projects in it. Which one does this represent? Well, it might be the example subdirectory. Okay, we'll specify that, and that's where you actually go in to do the install. Now, we just take that idea and expand it to directories on your local disk. This is a little different because this is when you could potentially lock an editable install. As I mentioned, you can do this just for development and thus specify, I want this to be an editable install for the lock. But this is also why it's only a path, there's no URL. And once again, that whole fun little subdirectory thing. Lastly, source trees can come in a random archive format. This is very underspecified on purpose because the direct URL.json spec underspecifies it. There's no specific, you must support zip files, you must support tar files, you must support, I don't know, some other old format from the 90s that I can't remember right now from when I was a kid. But once again, you can specify the URL or the path. You can specify the size. It's technically optional just in case it's expensive to get, but it's there just as a very minor protection against denial of service attacks. If someone says, oh yeah, I get this thing, we don't specify the size, and it turns out it's like 20 terabytes. If you specify the size, at least you can guarantee you know a max size and you don't go past it. Upload time is just one of those pieces of information for you to be able to just look at it and go like, why the heck is that uploaded just like last month? That makes no sense. Hashes is another bit of that security stuff. You don't have to do this by hand. The code should do it for you, your locker, and it just records the hashes of the file so you can make sure, once again, you get the exact bits that you're expecting. And then once again, that fun subdirectory. Okay, so source trees, done. Next, sdis and wheels. As I mentioned, those are things on Pypi. That's something you search for. Right? It's not I want this specific path at this commit or this URL. It's no, just get me requests. I have version requirements, but I don't know which version I want. Just find it for me. So that means you can specify the index. This is useful for Perls and some other security-related stuff. SBOMs. So there's a bit of usefulness for having this metadata in there. But basically everything after this, you theoretically will be searching for to try to install, including SDIS. This is probably fairly self-explanatory after talking about this for archive files, and actually, if you read this back, a lot of it just says, go see what's in the archive section to understand what this field's for. So I'm not going to go into too much detail on this one. And then wheels is a little, oh, by the way, one interesting thing, there's only one entity for SDIS because you don't have multiple copies of the same source for the same version of a project. But wheels is actually an array. And the reason this is, as you know, you're going to have a lot of different wheels for the same project. So the key thing here is the name bit, because as I mentioned earlier, a lot of details in that wheel file name. So that's going to be an array of lists, and then your installer is just going to look through it and find the best wheel for you and choose what to install, just like pip does already. Everything else is exactly the same. And then this gets us to one of the more interesting pieces of security information that can get recorded now, which is attestation identities. This came from PEP 740 by William Woodruff, Facundo Tuesca, and Dustin Ingram. And effectively, this is where, if you've heard the term trusted publishing, this is part of that. So basically what this records is, let's say you upload to Pypi using GitHub Actions, okay? So one of the things it could do is it can do this fancy security thing and say, hey, I can guarantee that this file, your wheel, your SDIS, whatever, was uploaded using GitHub Actions from GitHub, using this literal workflow.yaml file, using this environment defined in my GitHub, in the repo's GitHub account, and then you can record that here. The reason you might want to do that is you can then, at install time, verify that all the files that you want to potentially install came from a place that you expected, right? So if you know as a fact that Sebastian always uploads Fast API from the GitHub account for the org for Fast API, you can check, record that here, and the installer can go like, okay, did all the files actually come from the Fast API org and from the place I expected to? Because if it didn't, then someone broke into the account potentially that Sebastian has and just uploaded a random file, right? This way, at least you can guarantee that the build of that file came from GitHub. And the same thing for GitLab, and I think there's one other one. It's very locked down for very specific reasons. There are various blogs to read about those in more detail, but it's one of the nicer little security bits we added. Lastly, this is, almost lastly. This just records the dependencies. It's fairly free flow, it's optional, it's just there for you to be able to read and go, what the hell is this making me install, right? I don't know about you, but I always hate when it's like, how expensive is it for me having this project in my log file? Like, how much other stuff is this pulling in? Is it pulling in nothing? Is it pulling in 10 projects, 20 projects, 100 projects? And this allows you to figure out your dependencies and dependents to know, like, basically, why is this here, and what did this make me have? There's the packages.tool, which, if you're familiar with PyProject.toml, there's a tool table that basically tools can just put whatever the heck they want in there. Same thing, except it's per package. Nothing fancy. And just for good measure, tool is just like PyProject.toml at the top. So if you need more file level stuff, you can do it there. That's the file. That's it. That's all it is. This is the whole thing. This is the whole spec. Basically, whirlwind, Brett talking very fast, but that's what's in the log file format for pyplog.toml. So what the hell did we actually end up with in the end? We got artifacts, we got the source trees, we got the SDIS, we got the wheels. Thanks to those markers, we support multiple environments in a single log file. We got all the dependency groupings that everyone wanted via extras and dependency groups by adding those extra keys to markers. We got everything. And we'll cover why I'm still astonished that all happened. But if you want to just quickly talk about how to install, take the list of packages, iterate through it. Does the marker apply to this project, to this environment, yes or no? If it's no, skip it. If yes, okay. Does it support the right Python version? Yes, awesome. If not, you gotta stop because there's been an error somewhere. Double check that you didn't somehow have a lock file that listed the same project multiple times with different versions, because that's a conflict, because Python can only install one version at a time. Otherwise, add it to your list of stuff to install. And then for everything you got listed install, choose the best way to do the install, and that's it. I'm actually not oversimplifying this. If you go read the spec, I have an outline that's more or less this, with a little bit more detail, but not by much. So the whole, as I said, one of the key things here was to make installs quick and fast, and that's why it's quick and fast. It was designed to be very, very simple and straightforward. So why the heck did this take 4 years? Okay, so it all started on an old website known as Twitter back in the day, where I made some random off-the-cuff comment, which I'm kind of known for. And Zuping Cheng, one of the pip maintainers, just mentioned how he kind of still wanted to have a interchangeable lock file format. And I said, yeah, I'm thinking about it. In case you can't read the date on the back, it says February 11th, 2019. So this is the earliest piece of evidence I have that I was thinking about this 6 years ago. As I said, this is therapy for me. So in 2019, there was a topic on discuss.python.org in the packaging subcategory, all about requirements.txt v2. It was just all of us just talking about it. There's 106 posts, and we were just kind of just chatting about, like, what would we want, okay? This bled a little into 2020 with 43 more posts. I got a bit preoccupied, though, with PEP 621, which I was the primary author on, and that's what got us the project table in pyproject.toml. So just busy with other packaging stuff, but we're still kind of talking about it. But come 2021, and where the 4-year marker starts, I wrote PEP 665. Zuping, who I mentioned earlier, and Perdue Gaydon got together with me in January of that year, and we decided to try to get this lock file format. So we did, and then in July we posted the PEP. So from July to the end of the year, there were 359 posts talking about PEP 665. So what was that PEP about? Well, that one was about, once again, why security and reproducibility, but we tried to simplify our lives and up the security by saying, only wheels. We don't care about Estes, we don't care about source trees. Why? Because both source trees and Estes require executing build backends, which is executing code, which is unreliable because you don't know if it's going to be something different on Tuesday versus Wednesday, and you don't want to typically install code at install time that you don't have under your direct control. So the assumption was, if you needed something from Estes or source tree, you do it out of band, get the wheel, and then just have that kind of sitting there on the side, and then you just use it if you need to, okay? Yeah, people didn't like that. 106 posts in January alone, and that was the month the PEP got rejected. Basically, people didn't like the idea that Estes weren't going to be there, and there was also a desire to lock down your build backends. So people wanted Estes, and they wanted even more logging. It's like, okay, fine. So 2023, 54 posts on just the general, I still want to have lock files. Okay, fine. So I'm stubborn and don't know better, so I decided to strike out on my own. I didn't decide to drag Zuping and Perdue down with me, so I decided to do it my way, and that meant I had to create my own proof of concepts, which meant I effectively needed to re-implement pip. I have a problem. So that year was when I started to try to develop libraries to fill in gaps in the packaging ecosystem for features that pip had that were not available as a library. So this is when I took, for instance, all steps proof of concept and finished it to make packaging.metadata. I wrote my own resolver using resolvelib. I did a lot of crazy things in preparation for PEP 751 in 2024. It was a very eventful year. In February, UV got announced, which threw a slight wrench in things because they also announced some features I was hoping to use my new resolver for, which was no longer needed because UV did it. I became a parent for the first time in April. And somehow, thanks to babies sleeping a lot when they first are born, I finished up this PEP and posted it in July. So all of those posts, all 974 came in the latter half of the year. So this is not spread over 12 months, but 6 months. That started with PEP 751 take 1. It was based on PDM, which was based on poetry.lock. It was basically a set of projects to install, much like the array we had earlier, right? Just a big, literally a set, and you just figure out for each item what to install and what not to. It supported multiple lock environments, and it locked for wheels and SDIS. Okay, great. UV was around now and iterating quickly, and so that led to PEP 751 take 2, because Astral wanted a bit more flexibility based on their own lock file format, because they could plug in stuff differently. So I came up with a graph format. So instead of having a set of all the packages and per one going like, does this marker apply? Does this marker apply? Does this marker apply? It was a graph of the dependencies. So plug into the graph, and if a node didn't match, you turn that whole node off in the graph, and you don't have to worry about it. It was same feature set. It was just more flexible in terms of plugging into the thing. Okay, cool. Thought I had everyone covered. I thought I made everyone happy. And then Hinnick struck. To quote this, since it just came up in long discussion, it looks like neither this PEP nor the discussions have no provisions for dynamic package version metadata. The foreshadowing earlier about specifying your version and being optional. I have to admit that I'm not deep enough in the topic to make a cogent argument with the PEP, but let me explain why I think it would be a mistake to pass it without. Lots and lots of talking, blah, 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 which led to Charlie March of Astral saying, to speak openly, I'm kind of bummed about it, but I find myself nodding along to this. Thank you, Hinnick. As we get deeper into this conversation, I'm more and more aware that this is the correct answer, that we should focus on installer interoperability and therefore on a more limited format that is closer to a standardized, fully featured requirements.txt file in the PEP compile sense, i.e. way less than what I was after. There is a known hashtag, never fly with Hinnick, because Hinnick has very bad luck with getting on time with flights. I'm going to add a new one. Never let Hinnick comment on your PEP. And after last night, never go to dinner with Hinnick when you have a keynote the next morning. Yes, very specific. Okay, fine. So, not doing the graph. PEP 751 take 3, the 2025 edition. Bring back the set, basically back to take 1. Only works in a single environment because that was one of the sticking points. No extras dependency groups then. And at that point, as I said, we're in 2025 now. First comments in 2019, 2022, no, 2021. This is obviously dragging on. So I say, fine, all right. I'll do whatever it takes to get Paul Moore, the BDFL for packaging, to just accept this bloody thing. Sorry. Take this thing and just go in and just do it, okay? And I got really, really strict with the timelines. I started to say, like, okay, here's what's open. You all have a week to make comments. I'll make a decision then. Or this, only things that get to stay are things everyone agrees to between PDM, poetry, and UV, because the other ones already had lock file formats, and go, right? I got really, really, really strict with, like, what people could say could be removed but not added, timelines, everything. I got really militant about it. Partially because my wife had gotten really sick and tired of this topic, because this is not a on-work time only thing. This is a Brett talks about it constantly kind of thing, and talks about it constantly for 4 years. So I set a personal deadline of March 31st, and I thought we hit it. We had agreement. Awesome. That people liked this restricted list. Everyone agreed. And then Frost Ming, the PDM maintainer, stepped in. And I went, oh, it's very regrettable to see the recording extras and groups entering the rejected ideas because I didn't see any strong objection against this. Please point me to where it is otherwise. So Frost came and just like said, aw. Because Frost originally had said, you know what, if this works well enough, I will make this the lock file format for PDM. Right? PDM.lock would disappear, and pylock.toml would become what it used instead. So, can we have our cake and eat it too? Can we somehow make supporting extras and dependency groups work, and somehow also use multi-use environment support? And I don't know if this audience is old enough to get the portal joke at the bottom, but hopefully you do. But is there a way to make this work? Fine. 150 more posts, and very strict timelines again, and somehow, magically, on literally March 31st, PEP 751, which started this whole thing, the second time around, got accepted. I don't think I will ever forget that date. Anyway, it was very nice. Palmore accepted it as is. No changes, thanks to the version lock, because we're able to just do whatever, and we can update as necessary. So, 4 years and 1,800 posts later, by the way, the math is a little bigger just because I left out some of the smaller ones and the numbers, because I just got too lazy adding up every year. But this is where the support sits. And just keep in mind, this is less than 4 months after this all landed. PDM, you can opt in to make PyLock.toml your primary lock file format and your only lock file format. Both PDM and UV can install from a lock file, and you can create a lock file using PDM, UV, or pip. Pip will support installation, basically when there's enough volunteer time to add it. Pip Tools is talking about it. I believe pip env has a draft pip for it. Poetry is going to look and consider it, and was very active in the discussion, so hopefully it'll work for them, but they're also very volunteer run, so it's just dependent on how much time they have. But everyone's looking forward to doing this. Thank goodness. It would not be good if I did all that work and everyone said, nah, I'm good. Unfortunately, I think I went a little long, so I don't know if we have any time for Q&A. That's my website. You can find me on Mastodon and Blue Sky there, et cetera, et cetera. And that is it. Thank you for the therapy session. I appreciate it.
Hello. Hello. Thank you very much, Brett. I do hope the session was cathartic enough for you. Sadly, we do not have time for live Q&A, but Brett is easily findable, and I'm sure he'll be happy to continue his therapy session.
Yep, I'm here all the way through Friday, so.
That's excellent. And as a final note, before letting go for the coffee break, there was a last-minute cancellation on today's schedule. So at 10:30 in room South Hall 2B, the talk that would be there is not going to happen. Instead, it was replaced by a talk entitled A Tour of the Module ITER Tools. So plan according to that. Thank you and enjoy your day.